All right, here we go with section 9.2, graph and write equations of parabolas. Remember, this whole chapter is about conic sections, and this is kind of just a really kind of rough drawing of where you find a parabola when you cut a cone to get this section. It's kind of like you just slice it sort of right here, but you have to slice it parallel to the opposite side. I kind of showed you that in class with our model. So that's where you get the parabola from. It has to be parallel to the opposite side, and it does give you sort of a parabola there. Here's some vocab. We're going to have a focus, which is new. It's a point inside the parabola on the axis of symmetry. It's different from the vertex. The parabola focuses around the focus. I know it's kind of weird to say that, but here's what it looks like. You have this point here, and the parabola is around it. So it's sort of like a center of gravity. It's sort of like the same distance from the parabola all the way around. If you think about it, a pendulum swinging in a way. It's focusing on that dot right there. That's what the focus is. The directrix is a line perpendicular to the axis of symmetry. Here's the axis of symmetry. And the same distance away from the parabola as the focus, so you would just go to the opposite side of the vertex, and the directrix is a line outside the parabola. And we'll practice more with that. So right now, give the warm-up a try, pause the video, see how it goes, and come back to me. Okay, so here's the answers for the warm-up. This first one, all you have to do is you got to get y squared by itself, so that means you multiply, to get rid of this 1/2, you multiply each side by 2, and you would end up with this. Same with this, you have to get x squared by itself, so you got to get rid of the negative 1/6. And remember, instead of dividing by negative 1/6, you can multiply by the reciprocal, which is just negative 6. And this should be y. Sorry. And that's what you would get for that. And then here, identify the axis of symmetry for the graph. So really, this is how you get axis of symmetry. X equals negative b over 2a. And this is standard form. Remember, ax squared plus bx plus c. But we have no b and c here. So b is 0 over 2 times a, which is 3, which is 6, and that just equals 0. Now remember, the vertex is on the axis of symmetry, so the x-coordinate of the vertex is going to be whatever number that is. And then you can just plug that x into your equation, and you find out that y is 0. So the vertex is 0, 0. Same thing here. It says the equation y equals negative 0.016 x squared plus 16x models the path of a rocket. What's the vertex? Well, again, you can just use this equation to find the axis of symmetry, which is the x-coordinate of your vertex. And when you plug 500 into this equation, you end up getting 4,000. So your vertex would be 500, 4,000. All right. So let's talk about parabolas, which is a section out of the cone if you slice it just right. When doing conic sections, we'll use a different standard form equation for parabolas to help us identify the focus and the directrix, which is an important component of parabolas in conic sections. It's really kind of cool. So here, all the vertex are going to be at 0, 0 for this section. So our vertex will always be at 0, 0. And these are the standard form equations I was talking about. I'm going to tell you about those and what the components of them are. So first of all, if you have x squared equals stuff, x squared, as you learned, means a parabola that opens up or down. If x squared, then your parabola opens up or down. Okay, and then this part here, this 4p, if that's positive, when you're given an equation, that means the parabola opens up. And essentially what that means is that p is greater than 0. Okay, so I can just sketch this right now. I know my vertex is at 0, 0 for every parabola in this section, so I'm just going to kind of sketch a parabola that opens up. Now, the other thing we need to find is the focus and the directrix. This is supposed to be at 0, 0 here. Now I kind of showed you earlier that the focus is a point inside the parabola. It's a point, and it's kind of what the parabola is centered around. It's always going to be inside the parabola. And the directrix is a line outside the parabola. So the focus is always going to be the P. P is the focus. And if it opens up, you know that it's going to be somewhere here, and it's an ordered pair, which means that 0, x is going to be 0, and P is going to be the y coordinate. And then the directrix is a line exactly opposite this distance on the other side of the vertex. So I'm just going to kind of sketch a line here. Since it's a horizontal line, it's going to be y equals the opposite of whatever p is. Y equals negative p. And you can see p is part of the equation, which we'll be able to solve. And I'll practice that with you later. So p is the focus, and it's a point 0, p. And the directrix is a line, and it's going to be y equals negative p. So here is kind of the opposite of what we had here. This one opens up. This is all the same stuff. It's x squared, which means it's either opens up or down. But when 4p is negative, it opens down, which means that p was less than 0. So I'm going to go ahead and sketch that right now. This also helps me know that the focus is going to be somewhere here inside the parabola on the y-axis. So the focus is going to be 0p, and then the directrix is going to be opposite whatever this p is, and it's going to be up here, the same distance from the vertex, and it's a line. Y equals negative p. Okay? And then we're also going to see parabolas that open to the left and to the right. That's when you get y squared. When you have y squared, when it's y squared, it opens left or right. It's based on this right here. If it's positive, it opens to the right. And that also tells you that p is greater than 0. So again, our vertex is always going to be 0, 0. So I'm going to sketch this to the right. Which also tells me then the focus is going to be here inside the parabola on the x-axis, which is still going to be p0. It's just when it's a point here, you have to put p where x is, and then 0. And then the directrix is opposite the vertex, same distance as p, and this time it's a vertical line. So the directrix is going to be x equals negative p. And this is the focus. Focus is a point, directrix is a line. Okay, so here we have another y squared, and if this is negative, that means it opens to the left. And a is less than 0. So I'm going to just sketch that here. Again, my vertex is still at 0, 0. But this tells me now that the focus is here, also on the x-axis. And that's still going to be p0. And my directrix is going to be the same distance over here. It's a vertical line, and it's going to be x, whatever opposite of p. All right. Opens left. All right, so let's practice this a little bit. These are just the examples that we're going to refer back to. So right here, it says, graph the equation, identify the focus, the directrix, and the axis of symmetry of the parabola. All right, well, we see here that this is a y squared, so that immediately tells me that it opens left or right when it's y squared. Now remember that for this whole section, my vertex is at 0, 0. And since this is positive, the 20 is positive, it's going to open to the right. Now remember, the 20 is just kind of going to make it a stretch, but I'm just going to sketch it loosely here like this. And what that does for me is it now tells me that my focus is going to be somewhere here on the x-axis. And so remember, the focus is inside the parabola. It's kind of what the parabola swings around. So the reason you have to know the standard form is if we write right below here y squared equals 4px, this is just the standard form that I got from right up here, I can see then that, take a look at this, the 4p is equal to 20. So I'm going to use that. I'm going to say, okay, 4p equals 20. I need p in order to identify the focus and the directrix. So I can solve here for p. P is 5. Oh, so now I can go ahead and graph the focus. Isn't that nifty? Right here, 5, 0. So my focus is 5, 0. I know the directrix is exactly opposite the vertex. 1, 2, 3, 4, 5. And it's a vertical line because it has to be perpendicular to the axis of symmetry. So my directrix is x equals negative 5. And then my axis of symmetry is simply the x-axis, which is going to be an equation y equals 0. So you've done what they've asked. Not too bad. Let's do another one. Okay, here I see that this is x squared, which tells me that it's going to either open up or down. Okay, but what I really need to do is I need to solve for x squared. I need to get x squared by itself. So I know that I have to multiply by the reciprocal of this, negative 4. So it's going to be x squared equals negative 4y. And I got x squared by itself. And then all I have to do now is write in the standard form right below here, x squared equals 4py, because I need p. I need to identify what p is. And I can tell here that 4p is equal to negative 4. So I'm going to set that equal to each other. And I find that p is negative 1. All right. So based on this equation, I can see that it opens up or down. Because this is negative, I know it opens down. So I'm going to sketch it down. And this tells me that my focus is negative 1, 0. Right here. Excuse me, 0, negative 1. So I can write that down here. Focus is 0, negative 1. I know my directrix is exactly opposite that on the other side of the vertex. And the equation of that line is y equals 1. And then my axis of symmetry is going to be the y-axis here. Axis of symmetry is x equals 0. Of the equation of the parabola with vertex at 0, 0 and the given directrix of the focus. So I know that this is horizontal because, or I know the directrix is horizontal because it's y equals 2. So if I just think about it real quick, so I know if I sketch just a quick drawing here, y equals 2, here's my directrix. That means it tells me that my parabola must open down. Therefore, I'm going to use this x squared standard form. Okay? And I know that my directrix is the opposite of p. So p equals negative 2. So I'm going to plug in what I know. I know that p is negative 2 because it's the opposite of whatever the equation of this line is. So x squared equals 4 times negative 2 times y. Therefore, I can just write the equation. Look at how cool that is. Negative 8y, and I'm done. You just have to remember that P is the important number. All right, let's try another one. Oh, let's think about this. This is a vertical line. So my directrix is over here, which means that my parabola opens left, which means it's the y squared standard form that I have to use. And remember, P is the opposite of whatever the directrix value is. So P is -4. So I'm just going to plug that in. And y squared equals -16x. And there's my equation. This time they gave me the focus. So automatically I've been given P. Okay, but sometimes I still have to think about, okay, -2, 0, -2, 0 is here. That means the parabola goes around the focus, which means it opens left, which means it's a y squared. Y squared equals 4px. So I'm going to plug in P. And I get this. -8x. There's my equation. Not too bad. Okay, here a flashlight uses a parabolic mirror and a light source. Write an equation for the mirror's cross section. So we kind of want to look at this as the focus. And here, if you think about it, here are your x and y axis. Okay, and this is 0, 0. So it's kind of cool because if you, I brought this flashlight in, I don't know if you can see it very good or not, but in the bulb in there is the focus, and what happens is the light comes out of there and it reflects off the bowl that it's surrounding it, which causes the light to come out as a big beam, not just directly from that light bulb. And that's exactly what this is. The light is reflecting off the whole bowl, the parabolic bowl in there. So we can see that that this opens up. So we're going to have an x squared equals 4py. And we need to know what p is, and it says right here that the focus is a ½ inch up. So my focus is 0, 1/2. Oh, not negative, sorry, 0, 1/2. So I'm just going to plug in, and remember that's my p. So I'm going to plug that into my equation. And x squared is going to equal 2y. There's my equation. Simple enough. All right, now it says how deep is the mirror? So I kind of want to know how deep that bowl is. So what you do here is, it's not where the focus is actually, but I want to know how deep the bowl is. Okay, so the depth, if I think about it, is going to be the y value at the outer part of the bowl. So if I kind of go down like this. And if this is the x and y axis, I know that this point is 2. It's 2 over here and 2 over here. Okay? So this is actually going to be at 2 here as well. But let's figure out how we would use that. So it's the depth is the y value where x is 2. Okay, so if I plug that into my equation, x squared equals 2y, I want to know how deep it is where x is 2 here. So I'm going to plug in 2 for x, and then I get 4 equals 2y, and y equals 2. That tells me that it's 2 inches deep. However, it's not always going to be 2. It's not always going to be this distance here. That's just kind of a coincidence. It will not always be half the width. If you have any questions, list them here and we can go over them in class tomorrow.